For the second part of this section, we're going to start talking about perpendicular lines. So, you probably have heard of perpendicular lines before. If you remember, they are lines that intersect at a right angle. You'll actually be discussing these a lot, probably next year. Here's a few pictures of them. So they look like that. They intersect at a right angle. So you're going to be looking at those pictures a lot next year in geometry. However, in this class, the important thing that we're going to look at is the algebra behind these. And this is a little bit challenging for a lot of people, but it's important. You're going to use it a lot next year in geometry. So the key thing you need to know is that if two lines are perpendicular, their slopes will be negative reciprocals. And I'll show you what I mean in just a second. Okay, so some examples of negative reciprocals I'm going to give you. Then you'll see what I'm talking about. The first one I'm going to give you, let's say you have 4 over 5. So the negative reciprocal of that would be changing the sign, making it negative, and changing it to 5 over 4. So I want you to see if you can do the same thing with a few more of these. So for 5 over 7, the negative reciprocal of that is going to be negative 7 over 5. So negative 1 over 3, that one's a little tricky. The negative reciprocal is now going to become positive. So instead of thinking of it as negative, it's actually going to be the opposite sign reciprocal. It will become positive 3 over 1, which is just another way to write 3. The reciprocal of negative 4 is going to be negative 1 over 4th, but we change our sign and it becomes positive 1 over 4. So you are going to use those ideas for the next type of problems that you do. The first type of problem you'll see in this section is where I give you a set of lines and you tell me if any of them are parallel or if any of them are perpendicular. So the first step for this type is to find the slope of each line. So you're going to find the slope of each line. On every test and quiz, I usually only give one of these because they do take a little bit of time because you do have to be doing a lot of work. So starting with line A, you have to find the slope by getting this in slope-intercept form, which means you solve for y. So you solve for y, you add x to both sides. You then divide everything by 3. That gives you y equals 1/3 plus x over 3 is the same thing as 1 over 3 times x, or 1/3 x. So line A has a slope of 1/3. And if you want to just write up there, that's fine. Line B, luckily, I actually made this one nice and easy for you by giving you the actual slope within I wrote it in slope-intercept. So it's y equals negative 3x plus 1. Your slope is negative 3. The last one, line C, does require a little bit more work than B. So you're going to take this one, write it in slope-intercept form, use the way that you learned in the previous lesson from a few chapters ago where you had to solve for y. You're going to divide everything by -6. You end up getting y equals -2/3. Minus over minus is going to become positive. 2/6 is the same as 1/3. Make sure that you're okay with the fractions here. In this case, it's really, really important that you know those fractions. So this one also has a slope of 1/3. So now, when you go to write your answer, you need to put several things. You're going to have to write if any of them are parallel, and if any of them are perpendicular. So, by the way, if you find out that none of them are parallel or none of them are perpendicular, just write the word none. Don't just leave it blank, make sure you write none. So, parallel, you'll find that lines A and C are parallel because they have the same slope. So that's our answer for that. Now, perpendicular, if you remember, two lines are perpendicular if their slopes are negative reciprocals. So A and B have slopes of 1/3 and -3. Those are actually perpendicular. In addition, B and C also are going to be perpendicular. So that would be how you would do that problem. It's a little long, but it's an important thing to learn, so you need to make sure you know parallel, perpendicular. You are going to be using this a lot in geometry next year. Our next type of problem is similar to the problems we were doing with parallel lines. So we want to find the equation of the line that passes through this point -6,3 and is perpendicular to y equals 1/3 x plus 4. So the equation, the line that we're trying to find, I'm going to refer to as our new line. This one right here, the one that it's perpendicular to, I'm going to call this our original line. So our original line has that. Our new line, we know that it passes through this point. That's really all we know for now. However, we can use those things to help us figure out what this equation is. So our original line, if you look at the equation, you can see that it has a slope of 1/3. Now, this is the tricky part. Our new line does not have a slope of 1/3. Our new line is perpendicular to y equals 1/3 x plus 4. So our new line is actually going to have a slope of the negative reciprocal of 1/3. So our new line is going to have a slope of -3/1, which is -3. So that's what we're going to use for that. The other thing we know is that our new line also has the point -6,3. Just a reminder once again, for this type of problem, this +4 in that original line equation, completely useless. You don't need to use it for anything. You can feel free to cross it out. So now we know our new line slope and our new line point. We can use point-slope form. So to get our equation, I'm going to use y minus y1 equals m times x minus x1. I'd like you to write it in slope-intercept form. So when you start out, you get y minus 3 equals -3 times x plus 6. Make sure that you make that positive since the 6 is originally negative. Now, if I told you to write it in point-slope form, you could have just left it there. Or even based on the directions I have written them, you probably can keep it there and I wouldn't mark off any points. However, I just asked you, please write it in slope-intercept, so we're going to go a little bit further. We're going to distribute that -3. Don't forget to also distribute the negative with the 3. Now, we are going to move over that 3 on the left-hand side. We get y equals -3x minus 15. For this problem, I would like you to pause and try it on your own. So the first thing I'm going to do is I'm going to look at my original line. So I know my original line has a slope of negative 1/4. This 8 I'm going to just cross out because I don't need it. Now, my new line is perpendicular to that original one, and I know that its slope is the negative reciprocal of negative 1/4, so its slope is going to be positive 4/1, or just positive 4. I also know that it passes through 5, negative 4. So now I can use the point slope form to write the rest of this equation. And I will end up getting y plus 4 equals 4 times the quantity x minus 5. Now you can distribute, and then when you subtract 4 from both sides, you can get this entire problem into slope-intercept form, and you get y equals 4x minus 24. So for the last problem of this section, we're just going to do a little bit more practice with things that are perpendicular. So my original line in this case is y equals 4x plus 2. Ignore that 2, you don't need it. My original slope is going to be 4. Now this problem is a little bit harder than the previous ones because my new slope ends up being a fraction. So my new slope is going to be negative 1/4. I also know that my new line passes through the point 4, negative 2. So I'm going to use what I know about writing equations of lines. I'm going to write this one in point slope form. You'll actually find it's not as bad as it looks, because when you distribute the negative 1/4, you'll end up getting y plus 2 equals negative 1/4 times x. Negative 1/4 times negative 4 actually is going to give you plus 1. If you want, you can work that out off to the side. We know a negative times a negative is a positive, and we know that 1/4 times 4/1 just gives us 1/1, or 1. So if you want to do that, feel free to. Then we just subtract 2 from both sides. We end up getting y equals negative 1/4 x minus 1.